Welcome back again to Advanced Functions MHF4U 1. In this lesson number 6, we are going to talk about piecewise function. One of our learning goals today is to understand properties of piecewise function and be able to draw them. Now let's see what is a piecewise function. So it requires more than one formula or one equation to define a piecewise function. Now each formula is on a different interval. So that means that domain X has to be restricted by the union of all the intervals. So when you're representing the piecewise, different equations are represented within their own specific domain. For example, piecewise function is represented with f at x equal with a big squiggly bracket, and you represent, for example, x minus 2, x minus plus 4, or x squared minus 7. And then you're going to represent all these three different formula based on domain. Now keep in mind the domain, they have to share the same domain in order to be a piecewise. So we could say x is greater than 2 or equal to 2. And then I could say the x over here is in between 2, but not including, and let's say 0. And then in this case, I have to share the same domain with 0. X is less than or equal to 0. So the first two has to share the same domain of 2, and then the last two have to share the same domain of 0. Let's take a look. Graph the following piecewise function. So we are given three different formulas under the same domain. That's important to check. So I'm going to draw the grid and label 2. Okay, so this is the area that I have to pay attention to. So for the first one, I'm going to plug in 2 into the first equation. So when I plug in, my output is going to be negative 2. F at 2 is going to be negative 1. And for my third equation, if I plug in my domain, 2 is going to be 0. So let's see. So when x is greater than 2, it's going to be negative 2. So, x is, so 1, 2, when it's at negative 2. When x is greater than 2, I'm going to start at negative 2, but it's not including negative 2. So it's going to be an open circle, and it's going to go this way. Okay. Now, when it's at when x is 2, y is going to be negative 1, and it's equal. So therefore, it's an equal, so it's including at. So I'm going to draw a closed circle at negative 1. And when x is less than 2, my y value starts at 0, and it's not including. So I'm starting at 0, open circle, and it's a parabola. So it will look something like this. Okay, so this is a piecewise function that represented by three different formulas based on the same domain. Next, write the function as a piecewise function. So you may think that the square root and square, it cancels out, but you have to be careful about negative. So for example, so if I were to simplify this, it will become square and square cancels, it's x. But keep in mind, what if I were to have a negative? So when I plug in negative into x, I will still get positive for the negative value. So therefore, if I have to draw this, it's going to be an absolute function when you have square root with square. So it will look something like this. Okay, now we have to put it in a piecewise function. So let's find the domain. So you let x equal to 0, and the same domain that they're going to share is going to be 0. So we could say f at x. So I could say positive x when x is greater than 0 or equal to 0. And then I can say it's negative x when x is less than 0. And it will look like this. So I divide it into two sections, one positive and one negative. Question 3. So what value of the constant c will this function make it continuous? So again, identify that they share the same domain of 2. So what I'm going to do is I'm going to plug in f of 1, 2, plug it in. So it's going to be 2 plus c. And f2, the second formula, plug it in. And it's going to be c 2 squared plus 1, which is 4c plus 1. And in order to be continuous, they have to share the same y value. So I'm going to say f of 1, 2 is equal to f of 2, 2. So 2c, 2 plus c is equal to 4c plus 1. So let's collect the like terms. So 2 minus 1 equals 4c minus c. 1 is equal to 3c. C is equal to 1/3. So when c is equal to 1/3, this graph the piecewise function is going to be continuous. Now, this is a review for absolute value function, is that if it's an absolute, you always divide it into two sections with the same domain. When f at x is greater than or equal to 0, it's going to be positive. But if it's less than 0, then it's going to be negative.